Good morning. Good morning. Right. Welcome. My name is Guy Barudin, Masters of Science in class of 1987. I'm honored and pleased to introduce our guest speaker this morning, Professor Georgia Perakis. Georgia Perakis is the William F. Pounds Professor of Management and a Professor of Operations Research and Operations Management here at MIT Sloan. Professor Perakis teaches courses on analytics, as well as optimization and quantitative models for managers. In her research, she investigates how to develop the theory and practice of analytics in order to solve complex problems in important applications that include utilities and retail, among other markets. Today, Professor Perakis will discuss the use of analytics in product pricing and how the implementation of such a strategy could substantially benefit the bottom lines of retailers. Please join me in welcoming Professor Georgia Perakis.
So good morning, everybody, and so wonderful to see some very dear and familiar faces. I promise I won't give a final exam today. Although my current students from the Executive MBA program here at MIT are currently taking their final exam. So we will all be thinking of them right now. So, for those of you who do not know me, my journey started in the island of Crete in Greece, where I was actually born. I first studied math in Greece, in the University of Athens. And then my journey started about 30 years ago, I hate to say, here in the US, when I came temporarily to do my master's and PhD at Brown University in the Applied Math department. Yay. 30 years later, I'm still around this area. I never moved. And I actually started teaching in 1990 when my thesis advisor passed away during my PhD studies. And that's how I got to become a professor. And I haven't stopped ever since. I did start on the faculty in 1998. So I'm now happily closing 19 years here at MIT Sloan. I have to say, I felt I started last year. I have served in a number of administrative ways, including having served for 6 years as the co-director, faculty co-director of the LGO program, which some of you may come from that program, I'm not sure, but it used to be called LFM. And proudly, I have to say that as of July 1st, I will be the incoming faculty director of one of my dear programs, the Executive MBA program. So I look forward to that. And, of course, I believe very strongly in the use of analytics in various industries and the impact they can have, recognizing at the same time, from my own experience in practice and having learned the hard way, how basically organizational issues, communication issues, and so forth are very critical if you want to get people to implement and use analytics models. So currently, I work on various projects in the retail space, including with the one that I will present today, that's with the Oracle RGBU unit, but also companies like Inditex, and in particular Zara, IBM, the supply chain group, Johnson & Johnson, and others. But I also believe in the use of analytics in other spaces, and my experience takes me to utilities, to big ones, transportation, and so forth. I had the honor in the year 2000 to go to the White House and be honored in the 49 chosen scientists and engineers in the US when Bill Clinton was ending his term. And of course, I love MIT because it means that as a professor, I keep being a student. And also, I interact in my favorite activity with you guys, with students at all levels. And my aspiration is really at the stage of my career, how to bridge the gap between academia and industry. And that's what my research tries to do. Take analytics and go from theory to practice. And what I plan to do today is take you through a particular journey that me and my PhD students took and show you how analytics had an impact there. So what is analytics? First of all, who works in the analytics space? Can you please raise your hands? OK. Who works in analytics in pricing? I'm just curious. OK. Sort of, OK. So I say, what is analytics? Here's one definition. It's an approach to solve important problems that starts with the data, builds models to arrive at decisions that will create value. So it's DMD, one of our signature courses here at MIT, but with a V at the end, because you need the value, obviously. And as our Dean Dave Schmidtlein says, analytics is our prophetic science, and that's why the school has taken important steps in this area, starting with the new undergraduate major and minor in business analytics, followed with the MBA and Masters of Business Analytics that currently the first class is going through the journey of getting this master's degree in analytics. And finally, something that we intend to launch this fall is a new certificate in business analytics that our goal is to make it available for all flagship programs of the Sloan School, MBA programs, EMBA, Sloan Fellows, MFin program, and so forth. So you can see that the school is trying to have a presence in all offerings that it gives in different ways. So let me start a little bit with the process. What I found out is extremely important to do before you start any analytics. When you enter, for me, for example, as a faculty, I start the discussions with the company. The first order problem is to find what's the important analytics problem that's a first order problem for the company, which at the same time could have the potential to make an impact. Because clearly, when you go to a company, you might find many analytics problems. The question is, what's that one problem that if you address, it will really make a change? And of course, an extremely important second bullet is to make sure before you start that the data is there. Because I believe in all of this journey in analytics, you need the data to speak to you and guide you and lead you. And not, we came up with a cool model for a problem that we find important without having seen the data. The data have to guide you when you build your model. And the question is the data available? Where is the data available? Can you reconcile, if this is a big company, the different potentially areas that could hold similar data? And of course, the size of your organization will make a big difference. Is this a big company with different departments? Is this a startup? Two very different conversations. And of course, then is, okay, once you have the data, you have found what's the right problem, you have the support of management, and you are working closely with a team of people from the company. How do you find and formulate, find how to solve well, and so forth? And you will see, as I will talk today, that there are two parts to that conversation, typically. One is typically a predictive part, and another is a prescriptive part. And I will give you a concrete example in the space of pricing. Now, I like people to potentially ask questions, even if I'm speaking. Not while I'm speaking, but Please raise your hands if you are utterly confused, if you would like to say something. So I will take you through a particular journey, because till now I'm speaking pretty abstractly, which is about pricing. In particular, I will talk about a particular project with the Oracle Retail Business Unit and a group of students of mine. Some of them have already graduated and have gone on to be professors themselves. Others come actually from the ECS department, and Jeremy, for example, works for Microsoft, and some current students also. And this is the team from the Oracle side. And it is about promotion pricing. What do I mean by promotion pricing? In particular, this problem has to do with supermarkets. So you go to Shaw's supermarket, for example, and you go to buy Barilla sauce, and you see it's 50 cents off. Or, and as my students know, I love coffee. You go to get your favorite coffee, and you see that, for example, it's $1.70 off. So what are promotions? It's a temporary reduction of prices. In supermarkets, typically this week, they will reduce the price, and later on, it will go back up. And this is what is a promotion. And so a key question here is, you see these blocks represent, for example, a quarter that you are planning for. Which week should you actually reduce the price? Potentially not just 1 week, but multiple weeks within your quarter. How deeply should you actually reduce the price? Which week should you reduce the price? And of course, supermarkets are going to have to do this for thousands of SKUs. So doing this at the top of your head without the assistance of a decision support tool driven from analytics is going to be impossible. But I have talked to managers who believe that they can look at the data on an Excel spreadsheet and make such decisions, much to my surprise. So I think this is an important problem. And of course, the first question we asked the supermarkets is, why are they even interested to use promotions? Right? That's a first order question. Maybe they should not be promoting their products. And some of the answers that we got is, well, if this is helping us to increase our sales and to basically get people to buy this item because it wasn't selling well, that's a good idea. Or, for example, you may know how HP was selling the printers at a below cost, basically. And why were they doing this? Because they knew that they would get people to keep buying cartridges, and they would make money on the whole. And that actually has a name. It's called, as many of you may know, the loss leader effect. So increase traffic to your store. Now, it could be that this is a new item that you are introducing, so you want to get your customers to get familiar with this item, so you want to run promotions. It might be just that you want to bolster your customer loyalty, and you are running this promotion. It could be that promotions are a way to capture different segments of the population and do some sort of illegal price discrimination. Get, for example, the PhD students to buy items when the price is low, and faculty might buy it at a different price level. And of course, many people will tell you they will do it because their competitors are doing it, and it's what's called competitive retaliation. So I always ask this question first. Why do we even care about this problem? Is this a problem that we should even be solving? And of course, there are lots of quotes, here I have some, that are saying that promotions is a big business. For example, 7.66 billion revenue in the US and other numbers. And this comes from Oracle, which basically categorizes their clients into super tier, annual revenue more than 5 billion, tier 1, between 1 and 5, and mid-tier clients. And we actually mainly worked in this project with 2 clients that belonged in the middle, the tier 1 category. And they had around 1,000 stores with about 200 categories, each category having about from 50 to 600 items within the category. And that kind of gets to show you the scale, but I think also the last part is important, which basically is saying that on average, a supermarket will be carrying of the order of 40,000 SKUs. SKUs stands for stock keeping units. And at any given time, there will be of the order of thousands, 2,000 on promotions. So this gets to show you that these are large-scale problems that you cannot solve and address off the top of your head. And of course, that there are many companies that work in this space, many consulting type of companies that work in terms, it's not just Oracle, that work in terms of developing for clients pricing solutions. And now let's show you what are the problems that we addressed in this promotion planning journey. The journey starts actually with a supplier. Suppliers and retailers have what are called trade deals or vendor funds. So the first part of this equation is what are the trade funds that the supplier should offer to the retailer? How much discount will they offer to the retailer, asking in return to pass through at least how much of the discount to their customers. The second equation is now the retailer has a selection of various vendor funds to select from. What are the vendor funds that they should actually select? Then is the pricing, because now, for each of these deals, what prices should they offer to the customer? How much discount should they pass to the customer? And then, of course, in addition to, how should they promote each item? Should they promote it through flyers? Should they promote it in the supermarket at the end of the aisle? This is called an end cap promotion. Should they do BOGO offers, buy one, get one free? Should they have radio advertisements, Facebook advertisements, and so on and so forth? So this is the problem that says, OK, how do you actually promote each of these items? Each of these verticals has an important analytics and hard problem behind it. And the one that I'm going to address today, because I'm not going to keep you here the whole day, obviously, or you'll hate me, and that will really bring back memories from Sloan. I'm going to focus on the pricing problem, but a similar process and ideas applies actually for the other verticals as well. OK? Is this all clear? Does anybody have any questions that they want to ask at this point, or should I just move on? OK, move on. All right, so here's my definition of promotions. Sell the right product at the right time, to the right customer, at the right price. This is what I call a promotion, right? Now, it's not just about finding each week what price to put for the product that you are selling, but it's also, depending on the retailer, obey business practices and business rules that they have that are very important. And there are some universal business rules that are important across retailers that I will discuss next. And to my big surprise, when we entered this conversation with Oracle, which was about 6, 7 years ago, it was very much to my surprise that they claimed, and I talked to a few other software consultants who were in the same space, that the analytics tools were not there. I was actually shocked, to be very, very honest. And this is where finding the first order problem came into play, because when I started the conversation, I had a very different problem in mind. But then in the discussion and a few meetings, I realized that what I had in mind was not the first order problem. And then I was very happy to change course, because my interest is, as I mentioned, to bridge the gap between academia and industry. It's not just to write another random paper. So I said that business rules are very important when you do an analytics model in this space. These are some universal rules that I learned in this space that are important. The first thing is that prices are selected from a discrete price ladder. Why does it make sense that people use a discrete price ladder? Because there is the regular price of the product, and then depending on the space, for example, if you are talking about fashion, you are going to have a percentage discount of the item. And you are going to sell it for 25% off, for 50% off, 75%, and so forth. You will never see a discount of 42.527%. This statement, I hope, it sounds ridiculous to you as it sounds to me. When you are talking about supermarkets, you may have noticed yourselves that when you go to the supermarket, you notice that items end in 9 cents. Why do they do that? Because psychologists have found out that if they have the product before 99, you as a consumer anchor on the $4 and not on the fact that this is rounded really up and very close to $5. And that gives rise to a discrete price ladder. So A second business rule says that over your quarter, you want to limit the number of times you will offer promotions to the consumer. The reason is that if you offer too many promotions, then you are going to confuse and upset the consumer. So for example, you might say you want to offer promotions 2 or 3 times in the quarter. You will upset the consumer if you don't do so, and you will also destroy a bit the brand of the product you are selling. Another important business rule is saying that if you promote this week, don't promote again immediately the week after. Leave a separation till you promote again. Leave, for example, 2 or 3 weeks before you promote again. Try to space out your promotions. Otherwise, and I'll show you data actually, you will see that consumers will experience some fatigue from the promotion. You promote again and again, and your next promotion will not have the same effect. Yes?
So 2 questions. One goes back a little bit. You had said that you discovered that the first order problem that you were trying to solve was different than the one you'd come in with.
Yes.
I was hoping you could please clarify what you came in with or what you thought it was going to be versus what it turned out to be. But within the rules that you just put up here, did you do any work, or I would imagine it's possible to do some work in terms of whether or not those rules make sense? And then, what is an appropriate or ideal minimum time separation for maximum or minimum number of promotions in a period?
Yes, so on your first question, initially, I came in to try to understand the effect of online versus, regular, because I thought this is where the whole industry is moving. Then we went back to the drawing table when I realized even for regular supermarkets, they don't have such tools. So clearly, we had to go back and say, whoa, hold on your horses, and this is the first order problem that's not addressed yet. Okay? Now, how did we discover, this type of rules? This type of, let me finish and then I'll go to you. Those rules we discovered through conversations with them. The goal in building this type of decision support tools, they actually need to be decision support tools. They should never be replacing the managers because it's going to be hopeless for them to use it. So we try to leave those decisions up to the manager. And that's why the goal is to build a tool that solves very fast, in a very good interface, if it can run in Excel even better, so that they can actually get to decide themselves. Because in my experience, that's the only way you will get these people to use it in this type of industry. Now, you had a question.
This is a microphone?
I know, I said the same thing as you.
Sure.
Good question, yes, good point.
Thanks. Well, first, thanks for coming on Saturday morning to talk to us.
My pleasure.
So my question is, how do you define success of a promotion? Because, you're going to sell more, but at a lower price. You're going to cannibalize the other product you have next. People might stock up. So what's the definition of success of a promotion?
That's why you need to ask this question at the end and not now.
Okay.
Because I'll show you how we measured success. I'll show you how we actually very much addressed the issue of stockpiling, as you said, and so on. Very, very good questions, but I don't want to go to the end of my talk.
Okay, I'm anxious, sorry.
Yes. All right. But I like this. That's how people know that I like to run my classes this way. So, other business rules that we discovered. Limit the number of items that you put on promotion every week. And I've seen companies do this mistake in other spaces. I've seen this in companies that entered the online space, that up in the part that they were putting out the items that they were doing a sale on, and they put a huge amount of items, and then, of course, they saw that the consumer was completely confused. So, limiting the number of items you promote is very important. And other inter-item constraints. For example, trade deals might say that Coke and Pepsi do not want you to promote their items at the same time. Or, for example, if you're talking about a line on shampoo, a brand of shampoo, maybe you want to put all the items of promotion on promotion, but you'd better be careful, because you'd better make sure, for example, that the small size is cheaper than the larger size. So constraints like this. Yes?
These business rules are, I think, obvious, like small size versus larger size.
Yes.
But some, like the first rule, how do you know the first rule is correct to begin with?
So this is something that you might have negotiated in your contract with the supplier. So, Pepsi will come to you and will put it as a term that you cannot promote as a retailer the Pepsi product the same time as you are promoting Coke products.
The solution might not be the most optimized at the end.
Yeah, absolutely, absolutely. But you have to deal, obviously, with the practicality of things. So the models can handle a lot of things, but the question is, how do you get the retailers to implement it? And some of these constraints leave you flexibility. Now, what is the tool that we use to model this? Something that some of you may remember from when you took your DMD class here at MIT, integer optimization. I will become more concrete. But here's the whole picture, and what is in purple is some of the things that I discussed, and what is in green is some of the things that you want to capture when we will start next doing our demand modeling, which will be the first step in this. So in summarizing, what I will try to do next, and my philosophy, which I want to pass on to you, is that you obviously want to model the real practical problem. But in my experience, many times, these type of models become very complex if you want to capture every intricacy of reality. So many times, our goal as professors is to try to see how I can go from the complex model to a simpler model. If it's too simple, then I will not capture the real complex problem. So I have to find where to be in the middle. And that's what my first bullet here is trying to advise. And that's where a lot of part of the science in what we do comes into play. The second, and extremely important, you have to start from the data. You have to let the data speak to you, and whatever you propose, you need to make sure you do have the right data to estimate. And many times you might be surprised that this is not the case. Then, as I mentioned, in order to get managers to use any of this, it better be fast so that they can run a lot of what-if scenario, so that they can feel this is just a decision support tool. That's why you need your models to be scalable and run very fast. And of course, you have to let them be able to play with some of the things that you mentioned and potentially get interesting insights. And by the way, at the end of the day, they will not use any of this if it does not bring significant value from what they are currently doing. And as professors, we feel we are the smartest people in the world and whatever. And then we get humbled when we speak to practitioners and realize, actually, maybe they are not doing the optimal thing, but many times they have years of experience, and that counts for a lot. The a lot is bold-faced and capitalized. So it's not necessarily easy to accomplish the goal that I list in the end. That's my point here. So, for those of you that took DMD, you will see that there are two parts to this equation. First is going from the data to the models, meaning building some sort of a predictive model, and then going from the model to the decisions, meaning building some sort of a prescriptive model. And you have to do both, especially in the problem that I'm discussing, the promotion planning problem. So, as I said, we started with the data. And when you start with the data, a big part of the problem is collecting this data. And I have found out many times that the data that they give to you don't make any sense. And you have to go back to the drawing board and trying to make sense of this data, clean the data, aggregate the data, imputate the data because you might have missing values and so forth. Then you want to build predictive demand models that you can estimate directly from the data. And what we try to do in this work is to capture important consumer effects. How do consumers behave when it comes to promotions? How do items interact, as some of you mentioned, when it comes to promotions? Then capture the business rules of the retailer. And then, of course, optimize. And then, of course, try to find the impact of your model, starting with the data and do some out-of-sample testing, and then going to a live experiment where you see live how things work and what's the profit impact. In our work, we found for different products, for different stores, between 3 and 18% improvement, depending. And after this, you can actually take the next step of potential implementation and use. To do all of this, it's a very long journey, which took us many years. It's not done in a month, especially if you are an academic, in which case you also want to spend time to think about the science behind the models that you are actually proposing. So let me start with a tier 1 client, supermarket of Oracle. They had some data on customer transactions. We looked at many products, because I love coffee. I thought I'd show you coffee. Of the order of 250 SKUs, 32 brands, private and non-private labels. They were doing 18% of their sales in promotions. And this is actually a plot. That's why I call it data discovered. Here are all the weeks that we had from 2009 and to 2011. These are their sales. And what you see here are different brands. You can see the sales in different weeks. And you can see that down here, the blue is pretty stable. Turned out this was a premium brand, versus their red here was a non-premium house brand. So that's the one that they were promoting heavily. All right, so what do people do, this type of companies, Oracle, IBM, and others? Well, many times they will have historical data, typically of the order of 1 to 4 years. They will, every week, they observe the sales. They try to understand, learn the demand through an analytics model, do price recommendations that follow business rules. Then the retailers will review the promotions. They will make updates and implement the promotions that they approve. And this process will go on. And the analytics piece will lie in what I put in this rectangle. So in the data set that I'm going to show you today, it has 113 weeks of data from 2009 to 2011. We looked at 18 stores in this case, weekly brand level data. So we knew what was the week in the year, what was the store, what was the season, the brand and SKU, the sales volume, the prices that they used, the prices that they had the several previous weeks, and other item features such as the flavor of the coffee, the size, and so forth. And so this was the type of data that we had actually collected from them. And of course, we always teach students that when you build models, you basically divide your data either in 2 parts or many times even 3 parts. So you have your training set, 80 weeks from 2009 February to September 2010. And then the testing set is 33 weeks that we put aside, and we forgot we even had it, basically. So effectively, we are acting as if we are now in September 2010. This is the future, and it has not happened. And let's see how we can use the past to build a predictive model. And then, after all is said and done, and everything is cast on stone, then we see, OK, let's now go to the future and see how our model performed. Otherwise, you will be highly cheating. And I'm sure you've heard, if you torture the data enough, they will always confess to you. And that's not what you want to do in this case. And of course, you know what I tell my students, the first thing you do before you do fancy schmancy analytics, just plot the goddamn data and see what they look like, okay? That's the first step, plain and simple. Try to plot the data in any way, shape, or form that you can. For example, here I'm just showing you the price versus the sales quantity, and you can see that it makes sense that as the price goes up, the sales go down. That's something that's intuitive, for example. And you have basically the elasticity, but let's get a little bit more concrete. Because what I showed you before, yes, you can take a line and feed the data, but this might sound very naive. Is this what you want to do? So here what I'm showing you is 35 weeks of data, and the top is showing the price that the supermarket was setting every week. Prices here are normalized. So when I have here 1, it doesn't mean that the regular price was $1, but it's the normalized price. And you see that in week 4, there is a 10% of promotion, and so on and so forth. And what you see down here is the respective sales that they actually experienced. And you see that they are promoting 23% of the time for this particular brand of coffee, and it accounts for 41% of their sales. Which, by the way, that there are reports by Nielsen that seem to suggest same experience with other supermarkets. So the first thing that I noticed is exactly what I circled here. So what do you see here? You see something that, at least to me, seemed counterintuitive, right? Because you see that here, they are promoting deeper, but they have less of a lift in their sales. And then, after the promotion is over and they go up to the regular price, their sales are a little bit below to what it was before. To make a long story short, after we asked lots of questions, we made sure that this type of items did not experience stock-out effects and so forth. One of the explanations that we discussed was that basically there is what's called stockpiling, and somebody, I think, was it you? I don't know. Yeah, it was you? Yes. That there is a stockpiling effect that's going on, because this is coffee. Coffee doesn't go bad. It's not some sort of a produce that you are not going to stockpile at home because, if it's lettuce, forget it, for example. And therefore, when you build a model, this is a first-order consumer behavior that you want to model. Okay, so now you would say, sure, this lady goes to the supermarket to buy coffee. It sees it's on sale. She gets really happy, and she buys lots of coffee. And then she goes back next week, because I personally go to the supermarket every week, and you notice that there is a promotion, but now she remembers that she bought all this coffee last week, and therefore, even if it's cheaper, she doesn't buy. On the other hand, this guy, he has been going to the supermarket every week. He expects to find the coffee to be $10, and he sees that it's actually $15, bummer, and he actually doesn't buy. So this is a narrative that we've noticed, and we found even a supporting literature on it, that basically goes back to 1964 and so forth, that basically tells you that past prices matter. We will also let the data show this to us, but there is literature behind it. So past prices affect you, but not past prices forever. So what happened 2 years ago is not going to affect your buying behavior today, but only a few weeks in the past will play a role. Let's hear what Gerardo wanted to ask.
Yeah, I was going to ask you, with search pricing now that people are used to it, some other services, don't you think maybe the thought process of people is changing, and maybe this literature is different because now people are used to saying things can go up or down?
That's why, actually, you are going to let the data speak to you. This is just supporting evidence. It's like being a lawyer, right? So absolutely, you will not do this just because some paper many years ago said so. You will do it because out of sample, as I mentioned, it works with your data. But then having the literature to also say that this makes sense is good. So good question. All right, and then the first model that we tried in the data was to say, let's look at how demand for today is impacted by several features, including several past prices, but with what we will call bounded memory that we will discover from the data. We will not just come up with anything. So in the initial model we tried, we started with brand dummy variables, season, trend, price, and past week prices, and other features. So something that if you want to look at it, we started with a linear version and looks like this. And then we said, OK, one thing that we need to account is, as we said, past prices with a memory. So replacing this by putting some past prices. And now we will try with the data to see what is the right memory for which types of products and so forth. And just to give you an idea, let's say that you have here Folgers, Nescafe, and Maxwell coffee. So here's the brand, the week that you are at, the season, the current price, the past price, and the sales they've experienced. And now you will fit your model. So the first thing will be some sort of a linear regression. So you start simple. This is the out of sample R squared. And now you say, OK, let me go to the testing set and see how well did I do. I'm here, just here showing you a snippet. So according to the previous slide, this is the model that my regression found. And as a result, this is the prediction. And now I'm seeing what actually happened. Because I'm sitting in 2010, and this is the future. But the future, I know what it is. But the question is, how good is this? Are these numbers really good? Are these numbers really bad? What is actually the metric that I should be using? So the metric that we will be using actually will be what's called mean absolute percentage error. Or many times people will use in addition what's called a weighted mean absolute percentage error, which basically what it's doing, it's compare your prediction with the actual sales at each time period. That's why I abstracted. This could be, say, 13 weeks or 33 weeks, whatever my out of sample was. OK? So effectively, this will allow you to compare the actual, which is the red, with the green, which is what my regression on the total. So relative to the sales they experienced, on average, how well did I do? And what did we find out of sample in the end in this model? We found a mean absolute percentage error of 16.17%. Now you're going to tell me, is this a good number? Is this a bad number? So it depends on what type of industry you are in. If you're talking about fashion, where basically there's a lot of volatility, this is an amazing number. If you talk about supermarkets where people go every week, this is an OK number, but perhaps we can do better. So now I go back to this picture, and we said, let's try a few more models. And then let's have the verdict be the out of sample data. And now we went back to the literature, and this literature leads us back to Kahneman. Kahneman, is the Nobel Prize winner, who says the requirement to report effect in real time could enhance the salience of the worst and the final moments. So in other words, extreme experience, according to psychologists, play a role. And that's why we tried another model where we looked not just at the current price and the past week price, but also within a memory factor, what was the smallest price that they had experienced. So in other words, within, say, the past 4 weeks, was the minimum price of the coffee $7? And then what's the price they see on the shelf? And what was the price they saw last week? Just these three prices. Now, if this model is good, it has an advantage. The advantage is that the model doesn't require a lot of features. So just with a minimum price and what they are currently seeing in the past price, if that's a good model, that's going to be a good thing. Because it's also going to help you in terms of optimizing your promotions later. So to make a long story short, okay, it didn't quite improve. It gave us a very similar MAPE. So, all right. Now you say, well, let's look at the data. And let's try to see, as you see here, potentially there are nonlinear forms that I should try. So what did we do there? Is we tried a variety of nonlinear forms. In the interest of time, I'm not going to show you all the nonlinear forms we tried, but one that worked well, where we looked at the log of the sales with respect to the log of the price. And this is the previous model that I showed you. And here you can see that actually now you put the logs, and you can either try the model with all past prices up to a memory, or the one that just looks at the minimum price. Now, how did we do with that? Well, here is the linear, and here's the log-log model. You can see that the linear model now, the log-log model, goes to 11%. And let me now put what is called the peak-end model, which is the one that uses the minimum price. And let's look at what happened. You will see that actually now the peak-end model gives me the smallest mean absolute percentage error, that's 11.4%. So, and this is actually all the MAPEs that we saw in all 18 stores for this brand of coffee. And we didn't just do it for one brand of coffee, we did it for many, and we also did it for other products, but I'm not going to bore you to show all the findings. But, I mean, the best MAPE was in this store, which was 11.4%, and the worst was in this store that was 20.27%. Still, the 20%, which is below 30%, it's not amazing, but it's not terrible. And then we decided to go also to the machine learning tools and see if it was worth using something more sophisticated than linear and nonlinear transformations of regression. So we tried many models, one that's called a Gaussian process. And you see that now the 11.4% is becoming 10.52%. But I would say, yes, this performs the best out of sample. But I always caution people. I caution people because here there are trade-offs. And what are the trade-offs? That this machine learning model gives us the best out of sample MAPE, but to the retailers, it might sound much more black box. And now you have to ask yourselves, is this 5% improvement worth the black box potentially finding, okay? So I say you always have to ask this type of questions, and it's not, oh, this is the best model and that's the one you should use. That's sort of the second lesson I want you to take. Now, I won't bore you, but we didn't just try coffee. We tried chocolate, tea, yogurt, and we saw how the memory from the data changed depending on the product. You see, for example, in yogurt, the memory is 0, which makes sense because yogurt goes bad. So, you are not going to stockpile. We also noticed that whether this was a more luxury brand versus a more in-house brand, the memory changed. Because if it's a luxury brand, you love this product, you are going to buy it. Versus if it's an in-house brand that you don't feel so emotional about, you will not as much. So it's interesting always you let the data validate experience. You don't just use the data, and you don't just use experience and practice. You have to combine both. Now that we did this, we went to the prescription. And in the prescription, we said, OK, we have estimated the model. Now let's optimize. And what's the right objective function? What are the right decision variables? What are the right constraints? And what we did is we said, let's look at total profit in all the weeks in the planning horizon, look at the demand times price minus cost per unit. Decision variables is what price to set for the item in each week. And then we model the business rules I discussed, which is choose prices in the price ladder, make sure you limit the number of promotions per week, make sure to separate promotions and put inter-item constraints. I think in the interest of time, and I am happy to show you offline more details, after we built this model, we made sure it's solved within milliseconds. We then said, OK, let's try to see how we do out of sample. And I know that my computer is now not really behaving as well. What we are doing here is we are actually keeping the current practice of the retailer, which is that in 33 weeks they promote it 8 times. We don't change that, because that would be cheating. This is what they were currently experiencing profit, and with the same business practices, we show them for this product a 4.2% improvement. The running time was 0.05 seconds, meaning, and it was with a simple model that you could run it in Excel. So it runs fast. It can be run in Excel. Here I'm skipping the science where we showed analytically why this simple model would guarantee that you are very close to the actual complicated model. But unfortunately, I'm being signaled that I am taking too much time. And my computer also is somehow not behaving, but anyway. So then after this, we went to a live pilot. Now we said, OK, sure, all of this works fine and dandy out of sample. But let's actually try it in practice. The challenge with that was that, yes, Oracle liked me and my research. But implementing this live with a pilot might mean that if things don't go according to plan, Oracle could lose a client. And that's also a third-party intermediary. And this is not an online space where you can do A/B testing. So this is like the hardest place that you can do pilots at, as I have discovered. Because I always believe that the last step of this process is to try it live. Finally, we found somebody that there was a lot of good faith, a lot of pro bono work with Oracle and them. They agreed. They gave us their data. We started talking to their executives. And again, we found out as a first step that their data made no sense. Then we got all their flyers. Oracle put a data scientist to actually scan and pull out all the data, compare it with what their Excel sheet had. I, at that point, said, phew, here's value to them, because it shows to them how they were really not recording things correctly. So even if everything else doesn't work, this is value, I say. So we had to do a lot of cleaning and so forth. And then we had to select what are the stores that we would try our policy versus business as usual. And obviously, you want those stores to be in similar areas. But at the same time, you don't want them to be next to each other so that your customers will go from one store to another and you will confuse things. Similarly, with the products that you will select, including selecting products where stockpiling was something that we could find from the data. To make a long story short, we saw the order of 10% improvement, which was nice. So this is sort of the whole approach together that we try to do. Of course, for us as academics, we wrote a bunch of papers, which are very nice. For Oracle, we filed a bunch of pilots, a bunch of patents, I'm sorry. You can tell my time is up because I'm getting confused myself. Of course, we got some prices, but to make a long story short, what are some other aspects that I couldn't cover today that is where this type of industry goes at and we are investigating? The first is personalization. Here, the models that I talked about do not personalize the offerings. And where the industry is going versus giving targeted discounts to different people or different groups of people that you have, again, to figure out from the data. And then I say something that I have found. We all talk about big data, but you know what? In many instances, you have from little to no data. So the question is, what do you do then? I'm going to leave you with the suspense. But I want to show you to summarize what I tried to present to you today, which is what I call my summary of an analytics process, starting with what I started this talk with by saying, first, you have to discover what's the first order important problem from the company. Do you have the right support from upper management so that you can make a difference? Do you have the data available? Then you build a model that many times it will involve a predictive modeling and then an optimization or prescriptive modeling. Solving it might be challenging mathematically, but for me, that's the easy part. Then analyzing it and try to get some insights is important because that's what's going to allow you to communicate your solution to people that did not come to Sloan, did not take DMD, and so on and so forth. We talked a bit about testing things first out of sample, see in fact whether you have the impact that you think, compare with their current practice, see whether you are bringing, say, additional profits as you are hoping your model with, articulate and communicate to the broader company, and then, of course, convincing the different stakeholders, especially if this is a big company, to actually implement. This is not in my specialty, but those of you that were here in Sloan, this is what OP taught you. And there are so many moments I wished I had been through that OP class. And that's what is the collaboration that we like here at Sloan, not just me, many of my colleagues do, saying, okay, you work with an academic institution. First, is there an important problem where analytics can make a difference and at the same time can have general academic implications? Because also as academics, if this is not consulting and if this involves PhD students, we need to be writing papers and theses. I believe in very close engagement with a company because, as I said, experience counts for a lot. Access to data, being able to do a pilot, frequent meetings. In my opinion, at my stage of my career, I believe this is part of our educational mission, to have students learn about analytics and how it applies in practice, to develop important frameworks that might go beyond the model, and of course, I say, have an impact. So on that note, thank you for being here, and I hope I didn't tire you too much.